Good
morning, Mark.
Just getting the bureaucracy um, up here. So we got a new location for the IETF draft. And we have this document that I sent the link to. That I don't know, probably it's me, but it got completely blindsided that this even exists. Have you seen it?
I saw what you sent yesterday. I think it was yesterday. I just haven't. I went through it very quickly. I didn't. I kind of knew that they were working on these documents, but I just don't have enough cycles to just track everything.
Yeah, I
And
somehow
so,
did the TAC meeting conflicts with things I have at work every two
yeah,
Thursdays, so I don't um
it's not enough cycles. Too many things
yeah.
going on.
Yeah.
I mean, my
Oh,
reactions to all of these things is always the same. Is that identity is in fact the thing that is natively reimaginable with confidential computing. The fact that a piece of silicon now has its own immutable, confidential, and privacy preserving identity or ability to express itself and express a unique physical identity is the root of trust to rethink everything else. And every time I see a system that says, "Okay, I'm going to hang off of an existing," and I think it said the document says explicitly, we're not going to try to touch any of the identity infrastructure that's already out there. It's just, you undermine the essence of confidential computing. So,
yeah.
but, we live in the real world. We need to interoperate with the real world. But it does feel to me like the CCC not internalizing that identity is the killer app for confidential computing is what is, I'm mystified by that. But
Yeah.
someday,
Okay.
someday.
So well, the identity bridge is something I want to show you. I was hoping there would be a couple additional people on it, but let me start. Jeremy Powell. Hi, Jeremy. Hi, Hang.
Hello, hello.
I'm gonna start sharing my screen here. Let's see. Okay. And in the chat, I'll start putting some meeting minutes. Please add yourselves. And also, um, I want to show you this document. So this is not our IETF submission. I reached out to Simon. Simon is in the UK. And I wish I gotten to it sooner. But let me show you what they're talking about. Right. So look, the good thing is the problem is being identified correctly. We have a problem mapping attestation results to a real world identity. I like the identity bridge title, catchy. So there is overlap. But once you start getting into it, two architectural errors. One is that, well, one is I don't know if it's like an error. I think it's a nod to a lot of existing systems where we're basically saying, and this is, by the way, this is what's in production today, I believe, with the GCP as well. You do your attestation, and then you exchange attestation result through a STS, so security token service, for a token that is short-lived, which is still a bearer token. So they're basically saying, well, we're not going to do bound tokens, but we're going to mitigate the threat of bound tokens via a short lifetime. which is better than nothing. I still don't like it. The second problem is once you actually get into it and then just like read what they're doing, the claims model, they are still want policies around SVN and version bounds, audience restrictions, and like things that appear to be, well, take a look, hardware trust, versioning and freshness. And the problem, of course, is still does not make it possible for a workload to go to confidential from legacy and not require its relying parties to change. So I made that comment basically saying, look, for as long as you expect parts of an organization to move in concert, you are asking for trouble. So anyway, the document has every sign of an early draft. There is still a lot of room for instance. Simon cannot join us today, unfortunately. He said has a conflict. But this document, I just put the link in the chat. Take a look, comment. We can come back to it next week. Hopefully, Simon can also join us. So Simon represents Microsoft. It's unfortunate they didn't start working with us sooner and didn't occur to them. I literally learned about it last week. So, all right. So the IETF draft. Why is it here? Oh my God, this is a straight copy of what we had before with our credential acquisition method diagrams. And so there is nothing here that's new, is it? I literally just opened it because I asked Michael yesterday, send me the new location. But this has nothing. Oh, there's one commit. Let's see, one commit. What's that? I'm trying. Okay. Oh, there you go. So this is credential architecture.txt. This is new. Let's take a look at it. Why does it say 2 weeks ago? Did he really just create it 2 weeks ago? This would be the document. No, that's just the text. Sorry, I'm just trying to figure out. This is probably the document that he's talking about. Introduction. All right. This is not doesn't seem like it's a diff from our Google Doc. So quick recap. So today is the 26th of May. We have today and 3 more meetings with my participation to get this over the hump or get it submitted to ITF because after June 26th, turns out I have to disappear for 10 days. So
when is the IETF meeting?
well, so the ITF meeting is in Vienna the week of July 18th, but
Okay.
the submission deadline is July 6th. And because I'm basically disappearing June 26th to July 5th inclusive, and maybe through July 6th, that means that I will not be able to drive it past a month from today. Okay, but we still need to get it in, and this text does not necessarily like GitHub doesn't necessarily make it very easy to comment on things, but well, we'll have to do the best. But let's maybe do this. You see my screen. This is the doc that you can open in your own browser. And put it in the link here so you can click on it so you don't have to look at the screen. I want to take just a few minutes and simply review what this says and then figure out how we can comment. And I hope Michael will join us in a few minutes, but still just 10 past the hour. This is like, why do we need to put this text in? I don't even understand.
Yeah, this is a departure of what you had, right?
Yeah, it's like I personally would prefer that we go into, well, okay, let's open or contrast what it is that we have. So, okay. Which he didn't copy and paste, he just took this. So this I believe sort of goes directly for the point of what we're trying to do.
Yeah, he just rewrote the whole thing. It's not a
Completely like with the yeah, he didn't leave any
okay. So it's not a cut and paste at all.
no. But let's take a look at it, see if, if there are any nuggets of wisdom here that we can use, because all workload needs stable and trustworthy identifiers. He does talk about seat um, and auth bearer tokens.
Remind me what seed is again?
Seat is
Something eat.
it's basically an extension to TLS to incorporate a remote attestation into TLS. And because it requires both client and server to adapt, it's a non-starter. Like
Ah,
it's that's what I call a research project. Like you need to like so for instance, if you wanted to do MTLS with you know without modifying TLS, you would use our proposal to get certificates for both client and server. And that's it. You don't have to change your client and server. And Seed decided that it's perfectly acceptable to say, well, the client and server will change, and then we're going to live in this happy future. And like what I say, let them do it. It's just like they've been warned. So, um, see, I mean, bringing in something like saying that yes, we're doing certain things like with auto-mediated bearer tokens, but okay, conventions definitions I'm going to skip over for now, although he introduces credential broker.
so what do you want to do now? Because he's not here.
Well, no, I'm looking over it because we can at least take a few notes and bring it to a discussion with Michael, even when he shows up, and I can also talk to him offline. But so so one of the things he's doing that is a departure from what we thought was that there is a background check model here, right? That was not in our proposal. It's not invalid, but you're basically saying you're going to create a quote and send it directly to the credential broker. That thing on your behalf is going to contact the verifier to evaluate the evidence and then update the attestation results. That's fine, but it's a different, it's a different flow.
Yet
And
another one. Yeah.
well, yeah, right. And again, it's a variant, but it uh, I do not know if it's necessarily better or worse. Yeah, I would imagine it would make sense to document both. But okay, so here key
But
gap
hold
takes
on,
that
hold
as
on, hold on, hold on, because he says that the previous sentence is a credential broker is acting as a rights relying party. So it's kind of not a new role. I mean, he's basically saying it's an additional function that the rights relying party is doing.
yeah. So if you remember, so that we discussed, that is actually not a surprise to me. So uh when we talked was remember this picture?
Yeah,
Okay, see what he did here?
yeah.
Right? He's basically suggesting that we put a credential broker, recristant relying party as a credential broker. I
Hmm.
do not know what this foo thing is. I don't think we want to have a foo. But he did comment that we can have a credential like so basically what I tried doing in here when I drew this is I basically wanted to say look this the up everything up here is unchanged from rats. You still
Right.
have a relying party. And he wanted to basically give it another name. Does that make sense?
Yeah,
Okay, so now this RATS architecture, the RATS architecture does not have different pictures for passport check, for passport model and background check model,
yeah,
right? So it's six of one, half dozen of the other, like they say. So we could modify our document accordingly, basically saying you could use passport or background check model. You could go present your evidence to the verifier, or you can present your evidence to directly to the relying party. Either way, this this thing really does act as a credential broker, and it will return to you the ski or credential. So so far I my initial thoughts are that the introduction needs to be significantly shortened.
yeah.
Like I
I
think
agree.
there's a
It's
lot of
probably
stuff
the case.
here that
Yeah,
is but there could be some nuggets of wisdom to be kept from here. Now, credential broker, or to basically to have a statement that's saying the relying party in our proposal is still the RATS relying party, but it's not the ultimate relying party, it's the credential broker. And its goal is to make it work with relying parties that cannot change. And that is a good idea. And mentioning that we have, auth, whatever, based bearer tokens today is it's a recognition of reality, so not bad. But let's take a look because again, I can summarize these thoughts and I can give them over to Michael, and we can hammer out the next version. Okay, so new recurring worker connects to the credential broker to obtain a set of credentials to be used to perform its functions. Okay, grammar error, but okay. With this connection, evidence is transferred to the credential broker to demonstrate the workload's trustworthiness. Okay, credential broker is acting as a RATS relying party. The workload is the test. Credential broker connects using the background check model. But see, that one doesn't. It can be passport or background check, doesn't matter, right? So we can say that. Verify that it trusts in order to evaluate the evidence, obtain the attestation result. Fine. Okay, so then here's this picture called credentials arch. I'm gonna duplicate this tab. And then here we can go for his. Okay, so that's the draft. And this is the credential architecture. So, okay, so here's the picture, right? So a tester sends evidence to verify a relying party as the credential broker. So that the original document picture could be, and it's not enrollment. We're not enrolling anything here. So that has to change. But ultimately, verifier gives attestation results. And the important part is, whether it's background check or passport model, doesn't matter. What happens here is you're getting back a key or a credential. So there are basically two pivots. One is, are you using background check model or passport model? That's almost irrelevant either. But uh, the part that is relevant is your credential broker. It could be a key broker or credential broker. Key broker just gives you back a key, which means that enrollment needs to happen, uh, like we discussed in our provisioning phase. And what you get back is either it's a credential broker and you get a credential, it's a key broker and you get a key. So all of that can work. And I do not know what the hell work data is. It's really, you're just doing authentication with the credential that you just got or unlocked. Okay. PI. What is this?
I have no idea.
Oh, okay. No, this is sorry. This is the markup GUI for the renderer. So we already got through this. So okay, so he includes this text, the credential architecture text, fine. Types of credentials. Credential broker is also an identity provider, acts as a registration authority. It issues new credentials in form of PKX certificates to each trustworthy workload. Okay, fine. The second one, credential broker is a repository for a credential issued by another identity provider, and it discloses these trustworthy workload by encrypting these to an identity that identifies the workload. Okay, close enough. The credential broker is a repository for bearer token. See, this is probably necessary. I don't like it, but it's probably necessary. So if your relying party uses JOTs, bearer tokens, then this thing may in fact just give you back short-lived JOTs. I mean, this is... Hi, Hank.
Hi there. I'm a little bit distracted because of holiday season and kids and stuff, but I'm here
Okay, that's
and I'm
fine.
listening.
Yeah, we are at this point simply looking over the uh, whatever Michael Richardson had sent, and we're trying to figure out, how to combine, good resulting text from this. So we've been just going through the text and commenting, and the latest is the credential broker that is being introduced could give you back a certificate. Fair enough. Or it could give back a key, or it could get back a short-lived bearer token, which I don't like, but seems to be necessary. Okay. The use of a shared key, private key, is unorthodox. I don't know if this is good IRC language. Yeah, so no changes to the collaborating party required. This is good. Hank, question on IETF wisdom for you here. So when he says, specifically number 2 here, so the credential broker is a repository for credential issued by another identity provider, right? And we talked about that. We're basically saying the workload owner creates the key and a certificate or a credential, and it just makes it available to the workload. But here, he's basically saying the attester contacts the credential broker and gets back both the credential and the key. Does it matter that you really have two flows in one? In one flow, you get your credential. Credential is public, by the way, so there's no need to encrypt it. and the workload is already in possession of it. And it just goes to the credential broker to get the encrypted key. The second one is the workload goes to credential broker and gets back both the certificate and the key. I mean, are they sufficiently different that we need to document them separately?
Maybe, but I'm not entirely sure if the certificate is issued by attestation result or by evidence. That depends on the workflow.
It does. I've been thinking about it as the certificate gets issued. The certificate and the key get issued by, say, CI/CD pipeline, like whoever wants to deploy the workloads, right? And then if you think about the way like SPIFFE works, the workload can go to its agent and say, "Hey, give me my certificate," and that's perfectly fine. Certificate is public, go party. But the thing the workload still needs to do is it needs to go and unlock the use of the signing key for that certificate, right? In which case it goes to the credential broker. Credential broker in that case is basically an HSM, and the HSM will give it the key if attestation results are good, right? So again, that can happen either way, but that's the thing. Existing sources of certificates like SPIFFE, they don't understand, like they do not understand evidence. So if I want to plug into a flow such as SPIFFE that does not understand evidence, does not understand verifiers, all it can give me back is a certificate, and then it can give me back either a wrapped key or it can give me key ID equivalently, some opaque blob from which the workload is on its own to how it wants to turn that thing into an actual plain text key that it can use, right? So that's how we've been slicing it, and that has an impact on the protocol. And I'm basically saying, look, and this is where this will not be compatible with SPIFFE either. That's what I'm saying.
So the SPIFFE service is a credential broker?
No, well, it is
No.
today. It is today, but it is the way you interact with it, it has no concept of verifier. And
yeah, okay, which is fine, which is an add-on. So you collapse that role with a verifier or a relying party. Okay.
What I'm saying is, I believe the easiest way to move SPIFFE forward is to tell them no longer give me a plain text key, give me back a plain text certificate like you always did, and a KD. And the workload itself, without SPIFFE, will go and contact the credential broker or the verifier or the key store, whatever it does, to unlock the use of that key. Because then SPIFFE can say, okay, for confidential workloads, the workload is partly in charge for getting the key that it needs and doing remote attestation that it needs, and then they stay out of it.
Mm.
You see what I'm saying?
Yeah, I'm trying to do the strict demarcation line that you, I think, have.
So let me quickly illustrate what I mean here. So I filed this issue. This is the SPIFFE issue. Please feel free to take a look. This is the SPIFFE issue I filed to make them compatible with confidential computing. And what I mention here is I mention a quote to delegated identity API. This is what they have today, right? So take a look at this. There is a message that gets returned that gives you back, here's your plain text cert, and here's your private key. Plain text. And what I'm saying is it's not acceptable to us that you return to us plain text key. But then if you give me a companion message that returns the same thing here, but instead of the key, it gives me back a key ID or a wrapped key, and let me do the rest. Let me take it over from there. Then everything works. So basically, this is what see, we're not asking that remote attestation become part of spiffing. We're not asking that they become the credential broker that understands our verifier flows. Now, maybe we can ask and get it. I don't know, but I'm trying to basically ask for as little as possible.
Mm-hmm.
Because the alternative may be that we get nothing at all. So anyway, so this is what I mean when I critique this number 2.
I still need a more compact critique. So let me think this out loud. The credential broker is a repository for credential issued. Okay, so it's not the IDP. The credential broker is something different. It is a holder. I want to say holder, maybe presenter. I don't know what the term is here, but I think in the wallet concept, it's a holder because it's not the issuer. It's not the thing you present it to. So it's the man in the middle. So that's a holder. So the credential is a holder and has both the private key and the certificate, which again doesn't make it a holder. A holder doesn't have the private key. So now I'm confused because the issuer, the IDP, has probably the private key. Oh, no, I get it now. Okay, so the issuer is the signer of the private key, and thereby the holder has to be a wallet. Okay, got the private key. Sorry, confusion on my part. And it discloses these trustworthy workloads by encrypting these to an identity. So yeah, so I think what Michael is doing here is forcing a wallet function on the credential broker. Why is that bad? It has to have that, I think. What's the problem with being a holder?
Okay, so first of all, let me see. Let me list a couple of things that I agree with, so we can leave them behind. So if the credential broker is effectively a proxy for the IDP, right? So the workload wakes up, goes to the credential broker, provides evidence. The evidence like the broker uses the background check model to issue the certificate to the workload. Okay, and in that case, the private key.
So sorry, issue or proxy the cached?
No, in this case, actually issue a new one.
Okay,
so
then
this
it can't
number
be a
1.
holder. Okay, got it. So
The
but then 2 is
workload
wrong.
generated an asymmetric signing key that becomes the credential signing key.
Okay.
It provides evidence. The evidence is effectively a CSR. Credential broker is an IDP or a proxy for an IDP. It doesn't matter.
I see the problem now because the second bullet implies it's a presenter, a man in the middle, and you are highlighting the issue. The certificate is issued directly based on evidence. It is not only presented due to the exact evidence. It is created due to the presence of evidence or attestation aside.
Not exactly. That's not exactly what I'm saying. What I'm saying is the number 2 is the certificate exists and precedes the workload. It's evidence independent. The certificate.
But then it's a holder again. Now, first you said it is created on presentation of evidence, and now you're saying it is presented.
Here, in number 1,
yeah,
it is the certificate is created
on
demand by the workload. So if I have 2 workloads, they get 2 different credentials.
Okay.
Right, and the reason they get 2 different credentials because the signing keys are different. Each workload has its own signing key, and then it effectively does a CSR, and the credential broker is effectively then an IDP or a proxy for an IDP. And what is returned is a certificate, but no signing key is generated outside of the workload. So that would be number 1. Number 2, there could be 2 ways of doing it. It could be that the workload presents its evidence and an encryption key, and then the credential broker is okay. So it could be an IDP, or it could be there is a credential issue, right? But or the second one is the workload already has the credential, already has the certificate. And what it doesn't have is the signing key for the certificate. So then it goes
okay.
to the credential broker as effectively an HSM or key store and just gets back the key. And then that's the replica workloads. I have multiple workloads. They all were given the same identical certificate. And now each of them needs to pass attestation in order to get the key for that credential.
Yeah, okay, but again, there are two ways to do this. You can create you highlighted that for the replicas, they can have the same credential, correct?
Yes.
Okay, so it could be a holder that is only disclosing the credential upon reception of the correct evidence.
Yes.
Doing internal appraisal, I don't know, or external appraisal, depending on the model, and then releases key and certificate to the workload.
Correct.
Again, this is not issuing. This is holding.
Yes, correct. But I'm also only saying that there is another mode here. So there is 2A and 2B. Under 2A, it's exactly what it says here. The workload wakes up, goes to the credential broker. The credential broker is a holder of a certificate and a key, which it then packages up and sends to the workload. 2B is the workload has the credential, already given the credential by someone. What it doesn't have is the key. And then all it needs to get from the credential broker is, which at that point is just a key broker. It just gets back a key.
Yeah, but it provides, so how does it, so does a proof of possession somehow, no, what key? The private key?
So the private signing key is what it's after.
Okay, and how would it get that? So now, this is more difficult.
What I'm saying is in that model, when the workload wakes up, right, and before it did anything, it already has in its possession a key, a credential, a pre-issued credential, and a either wrapped key, signing key, or a key ID for the signing key. One or the other. But it has that. And now it goes to the credential broker and says, here's my evidence. Give me back my signing key.
Evidence, it also needs a signing key for the evidence. How does that happen?
The signing key for the evidence. The evidence is signed by the evidence is signed by the platform.
Yeah, but that's only platform. What about the workload evidence?
Oh, the same. It's the quote is signed, like it's platform plus workload signed by the platform.
No plus workload, because the workload is confidential. You cannot provide a TPM into the confidential workload. Okay, I mean it's a confidential.
No, it's standard.
The feature and the bug of confidentiality is it can't be invaded by the
No, I understand. But you like in either case, 1, 2, or 3, in either of these 3 cases, your workload still needs to provide signed evidence, and there is no difference in that.
And I'm asking, how does the workload acquire that relatively sensitive private key?
Okay, I'll show you.
Because you can go with evidence
it's all in here
that can issue or hold, and then you get it issued or.
But Henk, you were part of these discussions, so.
Yes, but I'm to be honest, it's like 3 weeks ago. So maybe walk me through.
Let me remind you.
Scenario where you do not have the private remote attestation key.
Yeah. But let me remind you.
The other key, the identity key. That I understand.
Let me remind you. So remember, we had this provisioning key. Okay, and remember we had 3 keys. We have the credential signing key. That's the private asymmetric signing key. You need that in order to use the credential. You need that for proof of possession.
The credential signing key resides with the issuer, so that's not really relevant to the.
Credential signing key resides in, well, the workload could be self-generating it, or it could be sitting inside the key store. So the way we did this in here, right, is inside the key store, we create the wrapping key and the signing key, and we generate the signing key inside the key store. And then what the workload does when it wakes up is it goes to the workload goes to the verifier. Well, this is the passport model, and it gets back attestation results, which it then sends to the key store, which then gives it back the encrypted wrapping key.
wrapping key. Okay, to unwrap something which is not the. Okay, I still don't know the evidence. The key to sign evidence arrives at the attester. I'm having a hard time to follow that. I now understand again how the so some unwrapping key for some signing key that already might reside wrapped on the workload is now exposed. Okay.
Yeah.
But that key is not for evidence because you only can get that key if you give it something evidence. So there must be another key beforehand, and I'm still not following entirely.
So the evidence is always signed by the platform key.
Yeah, you're repeating that, but that is only the evidence signed by the platform is this SMP, SVE SMP 4K byte
It's
blob.
right. It's whatever whatever your hardware gives you.
Yeah, it doesn't tell you anything about the trustworthiness of the workload. It only endorses that it says the workload, I don't know what that is, was started as intended. It can fail being trustworthy in 3 seconds. And so typically how you solve that, all these CMVs thingies have some kind of paravisor forced upon them, which bits, I think we had this discussion here, contaminating
Okay.
the workload.
Okay. So
and then you can assert the trustworthiness of the workload. And now the workload needs a signing key for its evidence. I understand that you can skip that step and assume that when platform remote evidence is created by the platform, the workload doesn't need to create its own evidence, but you have to really say that you're not attesting the trustworthiness of the workload, but what the evidence is about is that the workload, the static workload blob as intended was started, which can fail again after a few seconds and fail
but see, like I think that's it's a completely orthogonal issue because it doesn't matter which of these three methods you use. It's the exact same issue.
Okay, then I have okay. That is the exact same issue you say.
Yes. That's like at some point in time, the workload needs to provide its evidence to whatever we call credential broker here. It just needs to. It doesn't like it's exact same mechanism. The question is, what does the credential broker do with the evidence? It needs to examine the evidence. It needs to make decisions based on evidence. And what does it?
Yeah, but this is platform evidence now, which I understand is the only evidence that can be available in all scenarios.
Yes.
Okay. So fine, sure. Platform evidence is not hard to raise.
Platform plus workload evidence. All that evidence is.
No, there is no platform evidence, workload evidence. Zero. You do not have an evidence.
No. But of course there is because when you do evidence for a trust execution environment, it signs the contents of the trust execution environment. It's not just says you're running on this machine.
That is happening inside the TE, and a tester inside the TE needs its own private key to do that. The AIK, so to speak, if you use TCG language. And so, so the evidence signing key in the workload doesn't exist. We don't have any. What we do have is that the platform can provide evidence that about its own capabilities, that it's the right platform it should be running.
Okay.
Basically.
Today, when you start a confidential VM, how do you know that it's VM A and not VM B if they run on the same exact hardware?
The platform has a signing key and tells me that it started the exact verified signature payload here.
Okay, that's all we're talking about.
Okay, but then you are not talking about any workload evidence. I have to repeat, no workload evidence involved. Only
but the fact
evidence.
that this is the image that you started, that's the evidence.
Yeah, about some initial state that you do not know anything else about.
Okay, fine. That's perfectly fine.
Okay. I just wanted to make that very clear because
so,
that is no workload evidence involved here at any manner. that is very important to highlight in the text. And that is maybe the confusion we have, but you and I had for a long time, because I was always wondering how you would actually create evidence about the workload, but you don't. You create evidence about the starting of the blob that will become the workload from the platform. That is only half of the coin.
So I think this is an interesting and important point that you guys have detangled there. But Hank, how would you call that then? Because when I was listening to Mark, and workload evidence for me was the same thing as Mark was, imagining, which is indeed the hash of whatever code is being started by the platform. So how do you call that if you don't call that workload evidence?
That is platform evidence. The platform tells you that.
So
Platform creates evidence, and
hold on. I understand. But so platform evidence in my mind is everything that's hardware related. It's not independent of the actual code that is being started. What you're saying is that platform evidence in your mind includes both, so evidence about the hardware itself and some hash or some, value of the software that's being started. Is that what you call
that is
platform
the case,
evidence?
right? With SEV, SMP, that is the case, right? I'm not wrong.
I don't know. I'm a SGX guy, so
Okay, yeah, SGX is a little bit more simple, but I think that I can look this up again and not to make a mistake here. Sorry, but the SEV SMP 4K attestation report, in quotes, its literal name, byte blob, includes which blob was started. Evidence about that.
okay.
As
So
far
should we
as
call
I
it blob
understand.
evidence then, or is there a name for it?
It's proprietary evidence. So there's a field in there that tells you which thing was successfully validated and started.
And it is the same value if you run, the same blob, or if you start the same blob on all SEV, SMP, whatever.
No, the evidence should vary, I think, from platform to platform, but I'm not entirely sure.
How do you know that you have the right blob then?
Because the evidence is compared with endorsements from the vendor, and then you know the platform characteristics.
So you have
So
a
it's
way
not
to
compared, it's augmented. So it's augmented, it's not compared. So if you have certain identifiers here in the platform evidence, I think, as far as I understand, there is endorsements from that realm of that vendor, and that will be able to be tied to the evidence, and then you can augment it on a verifier with characteristics about its viability. Like these are the confidentiality requirements of my hardware. The hardware is identified, the TE stuff is identified in the evidence, and thereby you are able to now understand that this is the appropriate platform. This is how far I understand it works.
including the appropriate blob in there.
Yes,
So,
including the blob that was started, yes.
okay, so in your mind, when you use the word workload evidence, that you said, and that there's no signing key for workload evidence in your words, how would that ever be solved?
There are different methods here, I think, but I think that was the paravisor that people deploy today. So that paravisor is, for example, provided by all CVM environments, and it takes on the duty of an attester inside the confidential environment, measures it, and that also has to have the function to be enrolled or maybe provisioned. I'm not entirely sure what the correct term is. Bootstrapped with a attestation signing key. Maybe even the specific blob starts with a provisioning key that is always the same for blob. And together with the platform evidence and the provisioning key that you can do a proof of possession for, it then says, okay, by the way, I'm this blob running on this platform because it's tied and can do a CSR to the platform, or maybe they both talk to the same party. I don't know. Then you can entangle both messages, definitely, because of the blob can self-identify and the platform, of course, obviously can identify itself. And then you can say this is running, and then you get an attestation key because you're the right blob running on the right thing, endorsed by the right people, and
But
that is good enough.
hey,
Did you get that from where?
none of that matters because the same exact mechanism is used 1, 2, and 3. And so it's effectively orthogonal to the subject of this document.
As I was saying, it doesn't matter is maybe a little bit strong, but it should just be differentiated, and we should scope what we're talking about. And what I hear now is we're not talking about evidence created inside the workload as a complement to the platform evidence, but we're only talking about evidence created by the platform that it's correctly started, and that is enough for
No,
us
actually, no, that's not true. Because a
no.
very key part of the evidence submitted here is a key held by the workload. In all cases, you have to
Where does that
attest
key
to it.
come from? I cannot repeat that question.
Okay, so going back to this, the workload
Yeah.
generates a key. The
Oh, it does
workload,
it itself. Okay, so it generates a key and then it creates
and
a CSR.
that the public portion of that key is included in the, so see, generate evidence, including the public CDK.
Yeah.
Yeah. So
And then
in all
that
cases,
is the CSR, of course.
the
Okay, got it.
evidence
Yeah.
includes the everything about the platform, plus the workload code and configuration, plus the key generated by the workload. Right? And it doesn't matter which mechanism you use, that evidence still has to be, it's whatever you call that evidence, it's the complete blob. We don't need to go specify further what it is, because if we didn't have that mechanism, no confidential computing would ever work.
Yeah. Okay. So it's a compromise.
Well, it's an abstraction over a mechanism that already exists and works in practice today. It's like you don't actually need to go specify it any further because this is no different than any other remote attestation.
Um,
Like
I'm
all
hesitant to
forms of
agree with
remote
that.
attestation must have that.
So I have to take a call. I'm very sorry. I'm right back.
Okay.
And I'm right back. The matter resolved itself. So okay. I see better now. Okay, so the workload generates a key pair
Yes.
and then creates a CSR with that key pair.
Well, it generates an evidence, but evidence could be an
No,
input
wait,
to CSR.
no, okay, that is missing a gazillion ton of steps. You can't just generate a key and create evidence. That's not evidence. Now I understand the disconnect better. I don't know why I didn't see it before, to be honest. If you just create a key from nothing, from entropy, and sign stuff with it, it's called a self-assertion. Why
Well,
would that
but
be evidence?
it's not a standalone statement, what you call self-assertion. I agree with self-assertion, but it's not standalone. It's tied to everything else. It's tied to information about the platform and information about the workload. It basically it couples everything together. So you're basically saying, I'm running on this particular piece of hardware. I'm running this workload on this piece of hardware, and this
But it could have
workload is in
stolen all
possession of
that
this
and then
key.
signing it. So if
Correct.
you acquire some platform evidence from somewhere and then put it all into your message, it might be a hardcore attack. So
Oh
this is
no,
not
no,
evidence.
not at all, not at all. And the reason is that, for instance, in this case, the CDK is an asymmetric encryption key. So yeah, you can steal somebody else's public encryption key. You just won't be able to see the response because you don't have a corresponding private key in your possession. So you're
Okay.
actually safe. You don't there is no problem. And with the signing key, it's the same thing. For signing key, yes, you would have to create a CSR because then you would, and then subsequently you use the signing key to sign statements with that certificate.
Yeah, but that is what evidence creation requires. You need a signing key to sign evidence with it.
Well, the signing key is like ultimately everything gets signed by the platform, and then the
Yeah, and
verify
I
knows how to
think
interpret
the
those
disconnect.
statements. Huh?
This is, I think, there's a disconnect. So yes, everything is in principle signed by the platform. I would not agree with. Workload evidence cannot be signed by the platform because it cannot look
Well, so
into
there is a chain of
workload.
signing keys. Like it's still immaterial in the sense that it happens no matter how you do your attestation. Like for which of these, like regardless of which mechanism here you use, it's the same method of generating evidence.
No, it's method of generating a signed message, and that is the important part. Some of these methods lead to evidence. Some of these methods lead to trusted self-assertions, which is not evidence. And that is an important difference, I think.
Well, your evidence may contain an assertion.
Yeah. If
Okay.
it's evidence, it can have a part in it that is like a sensor reading. You don't know if your GPS is spoofed. You just read the GPS value and put it into the evidence. And everybody understands, okay, it's in the evidence, but it might be spoofed. So it's a quality of the value, a quality of the claim. Everything can be in the evidence, even things that you definitely know that they might have.
Yeah, you need to
not.
worry about like things like misuse, but like I explained with this asymmetric encryption key, if you stole the public encryption key from someone else, it actually doesn't matter. If you don't have the corresponding private key, you're powerless to do anything with it. Like you're attacking yourself.
Yeah, but there's no such thing as a public encryption key. There's only public validation.
That's not true. No, of course not.
Not?
Of
Okay,
course you can have,
no?
of course you can have asymmetric encryption keys. Like you can't with elliptic curves, but you can with RSA.
I'm confused. Which secret is used to sign the evidence? Not the public part, even if the RSA. I'm a little confused.
So look, we already talked about how evidence generation is, a complex mechanism, but ultimately, at the end, it's signed by the platform.
Some part, the most essential part and the most concise part is signed by the platform, correct.
Okay, so it could be
Starting
chained
of workload.
evidence where the platform signs for for what you call the pairvisor, and the pairvisor signs for something else. In the end, it doesn't matter. Either you trust the signing key of the platform or you don't.
Yeah, okay, that is true. The root of trust here is the platform, correct.
Correct. And then there may be intermediate roots of trust there for the, whatever signs the workload. And that's cool too. It actually does not impact what we're trying to accomplish.
Yeah, okay. So we are trying to accomplish startup evidence. This is startup, what we call it, boot time. The goal is to create only boot time evidence about the correct workload being booted in a confidential VM. That's platform evidence. And then providing to that workload that is somehow entangled with a CSR in this case, I assume, to the evidence created, creating a new signed statement that entangles them, proof of possession, you're calling it sometimes, I think. Then you get the key as a workload. And then now the key can be provisioned like with ESD to the workload.
Okay.
Okay, I understand that, but it's only based on initial boot time remote attestation and nothing else. As soon as the first service gets up, starts, the first untrustworthy thing happens on the
Well,
workload,
don't
it
run
immediately
untrustworthy
comes all
things
in that.
inside your confidential workload. Yeah, I think that's a good practice.
Yeah, okay, but we have to really say that, because that is a huge problem, that a confidential workload has this benefit of being confidential and then the bug of being confidential.
Yeah,
So,
if you run arbitrary code inside your tested workload, you void your warranty. That's all right. Lock it down.
well, you could have the parallelizer being forced upon you. Okay, I don't know if that's a great idea, but that one could take on another role of a tester, create workload evidence, because that
Yeah,
is
and
somehow
again, yes, you are correct, and it's also is orthogonal. We could basically say that we issue short-lived certificates, and if the paravisor wants to reattest after this with the new information, it's the same mechanism. You still generate evidence, maybe it's updated evidence, and somebody needs to look at it and say, is it still good? Like again, like it's very, very bad to confuse orthogonal axes, because it completely derails the conversation.
Yeah, but this is perfect. Now this is way easier problem than I thought we were going to solve. And now I can make more sense
Okay.
of all of it, I think. So yeah, we are focusing on platform evidence, and just have to make sure that the key inside the workload is tied to the platform evidence somehow.
Yeah.
Yeah, and that is just some key, and that some key is not an evidence generating key. So that is very, very important distinction, and that makes it way simpler, because now you can self-generate it. You can be a signing fool, and this is just as intended. Great. So that is there's a less very strong assertion about the integrity of the workload than I thought. The assurance level is way lower, and so it's very more easier to do all of this.
Well, I mean, easy is good in my book. Easy is fine. The problem
Yeah, it's a good
is
first step.
when
So
it still
yeah.
hasn't been done, is what I'm after.
Yeah, but it deconfuses me. And for me, that's helpful. Sorry.
Okay.
Okay.
We're
I
past.
think we managed to kind of talk past each other for quite some time here. And I think it was a very enlightening revelation for me. So thank you for that.
Okay. I was going to bring your attention to something because you joined later. So in the meeting minutes, take a look at this identity bridge document. This is from the CCC TAC. It's Microsoft PM wrote it, and it seems to be solving a similar problem that we're trying to solve. I have some critiques about it that you can read my comments on the document.
Is it from Alex, or who wrote it?
This is a identity bridge blueprint from the TAC. So, but you can click on it, look at it. My comments are in there. They're still bearer token based. They're basically saying we're going to use short-lived bearer tokens, and they still require relying parties to change. So there's some critiques, but the TAC is working on it, and I invited the author to come join us and have these conversations here. But for the next week, we need to somehow combine what's in. So this document that Michael started, so this one, I believe still needs some serious work. I'm going to provide some comments. Like the introduction is far too verbose and does not really address, what we started saying, which is, if you remember, we have a very short and sweet abstract. And it basically focuses on the fact that RATS does not support relying parties that want to change. And then it introduces credential brokers. So like there's some good things in it, but we need to basically somehow converge the text that we had so far with the text that Michael has proposed. And that needs to happen for next week.
Mm-hmm.
Because I also told people, like, so today is May 26th. I'm on vacation from June 26th to July 6th. July 6th is the submission deadline. So, I can participate for this week and 3 more meetings, and then I'm out.
Okay. So we have a good time window, very clear.
I think it's tight, but I think it's still. I think we're close. But yeah, we need to move
So end of
quickly.
June, I will be. Oh, is it still in the time frame? So when are you gone again? Sorry.
From June 26th, and then submission
Perfect.
deadline
Okay.
is July 6th. So I
Yeah,
would like to wrap it up in the next 3 meetings.
yeah. I will be flying to the TCG meeting in that week also. So I guess it's June 26th.
Yeah.
Although it's the June 26th, like in the middle of the week, right?
Yeah.
Yeah. Okay, that makes sense. Okay. Yeah, but that's a good time frame, and I have to talk to Michael about this, so we have a common understanding and come back with very crisp questions. How to phrase the scope of evidence creation? What problem is solved, so in scope, and what problem is not solved in scope, and then we can return to the 3 bullets, and I think that will be easy peasy.
Yeah. Well, what is solved by evidence creation is that's what I'm trying to say. It's completely orthogonal to this document. Whatever evidence you choose to present to the verifier today is going to completely cleanly transfer into this. And if you are worried about the fact that the evidence changes as the workload evolves, issue short-lived certificates, short-lived credentials, and force it to reattest periodically. The mechanism
Yeah,
is
but the
not going to
platform
change.
cannot reattest periodically
Why not?
because it is a confidential platform. It may not do that. It is not allowed. It is not a capability of it.
To change and to reattest?
It cannot see into the workload and see a change in the workload. Yes.
Oh, no. A workload can reattest itself, can initiate its own attestation.
Yeah, but then it does need again, we are there again, and then it needs a remote attestation key, which it doesn't have. It just has a randomly generated key pair.
Or it can generate another key pair.
Yeah, and that is just another key pair, still not evidence key pair. Again, an evidence key pair has special qualities, and these qualities have to be proven by the platform or by the attester that is the workload. Otherwise, it doesn't work.
Okay. That may need to be a separate draft.
Yeah, exactly. And now I get it. I was trying to force it into here mentally.
Yeah,
right?
I don't think that's a good idea. I think it would just confuse matters. Here we're saying, if you have a capability of generating evidence, generating keys, certifying keys, doing proof of possession, all of that, then this is how you can get a credential around, for
Yeah,
yourself.
but it's only about boot time. Initial
Yeah,
shot at the beginning, and then we're done.
I'm willing to say that, the workload owner can work on making sure that their workloads don't drift.
Yeah, and that is fine. And there can be a separate problem, and it can make use of the things that the platform or our procedure already created. It can tie into all these things, but it makes the problem way easier.
Yeah.
Much easier. Because the real problem is that the confidential workload is very hard to be enlightened and become an attester.
Yeah.
Okay, so because we were talking about enlightened workloads in the past, I always confused that with attester capability on the workload side, which we don't assume. I get that now. We just have key pair. And that is, again, I have to think about that, and I have to talk with Micah about it, so we can clear it up a little bit here, what he thinks. But that, I think, streamlines the next steps a lot. But I want to ask around, is everybody on the same page here in this group?
Well, other folks on the call have been generally quiet.
Happy? We lost Manu, unfortunately.
Yeah, Manu had to go.
Kevin is also from same affiliation. Okay. Then so we can go from there. That's again, I'm sorry for being dense for so long, but I think the term enlightened workload really made me think the wrong thing. I'm sorry.
Okay.
Because it's not enlightened. That's the fun part here. It is just some workload.
Okay. Well, I think that whatever mechanism we devise here, so long as you say, well, because you can change, and again, I've been thinking about this problem for a while too. a workload can basically say, every time I do anything to change myself, I'm going to invalidate my own credentials and go do remote attestation, or the credential
but
can
then
be
it's doing it on
short-lived.
purpose. But it can be done to, it's like an attack. Services can be compromises, vulnerabilities can be exploited, and all that should be detectable. And there's no means that we provide here to do that.
Yeah, and
That is out of scope.
Out of scope.
Yes, that's very important. The workload is not an attester, period. That is very, very important. And then it all collapses to a simpler problem. Yeah.
Okay. All right. I'll see you next Tuesday. Thank you.
Okay, bye-bye.
All right. Bye.
Bye.